All right, so today we are talking about perimeter and area in the coordinate plane. So here's the warm-up. Point S is between points R and T on RT. Use the information to write an equation in terms of X, then solve the equation and find R, S, ST, and RT. So R and T is the full length of the line. So we know that RT is 60. So knowing that, we can set 60 equal to the other two segments added together. So 3x minus 16 plus 4x minus 8. And from here, 60 equals, we know that we can combine the terms that have the x's in them. So 3x and 4x becomes 7x. The other terms that we have are negative 16 and negative 8. We combine those two and we get negative 24. From here, we just need to add 24 to both sides. And what we are left with is we get 84 equals 7x. If we divide by 7 from both sides, x is going to be equal to, let me just grab my calculator. You should as well. 84 divided by 7 is 12. Yep, even Mr. Yurko didn't know that one off the top of his head. All right, so that was the warm-up. Again, this warm-up was related to the segment addition postulate. Okay. All right, next I have polygons. So for a polygon, that means that it is many angles, so it includes more than one angle. Okay, it is a closed plane figure formed by coplanar segments called sides, such that, and then all three of these need to be satisfied. So let's write over here on the side, they all must happen. Okay, so each side must intersect exactly two sides, one at each endpoint, and no two sides with a common endpoint are collinear. Each endpoint of a side is a vertex of the polygon. Go ahead in this right-hand corner, I'm going to change colors. I recommend you do too. Put that it's closed. Closed and straight. Okay, so basically when we're looking for a polygon, it must be a closed figure and it must be straight lines. Okay, polygon. Okay, so let's go ahead. We have some examples so we can reinforce what we're learning. Identify the figures that are not polygons and explain. So for A, this is yes. It is a polygon. Why is it a polygon? Because it is closed and all of its sides are straight. Okay. For B, it is not a polygon. Why? Because there's an opening there. Not closed. And for C, now this one is indeed closed, but as you can see, if we pick any of these sides, they cross another side. That's a no-no for polygons, okay? And also, we have 4 intersections with sides. That is also a no-no, okay? So we're gonna put not polygon. We're going to put too many intersections. For D, it is closed, it is straight, yes, it is a polygon. For E, it is not a polygon. Why is it not a polygon? It's not even a closed figure. And at this point, right here, we have 3 sides intersecting. Only 2 can intersect at any given point, okay? All right, next slide. So convex polygons. On yours, jump over to convex polygons. That's this slide right here. So for convex polygons, the main thing that you guys need to know is that take any line that's on the side of the figure and extend it out forever like they did here. None of those lines are going to touch the interior. Okay, that's this shaded region in yellow. Okay, so let's try it out with this one. There's one line. There's another line. Another one, another one, another one, and another one. None of these lines are going to cross the inside of the polygon. Therefore, it is convex. Okay? Slide needs you to. Now for concave, it's a little bit different. So let's take the figure over here on the left. If we were to take a line and continue it forever in these directions, it 100% goes inside the polygon, okay? So when that happens, it is considered concave. It gives you another example right here. See how the red line crosses the interior? These are concave. If you want to think about it as a cave, you go inside a cave, right? Let's pretend this is a cave. I don't know, boulders, awkward. But you go inside the cave, right? So it passes through the interior. Just one way that you can learn remember it. You don't have to remember it that way. This might be the next slide. All right, moving on. So classifying polygons, these are just some names. So if if a polygon has 3 sides, it is a triangle. If it has 4, it's a quadrilateral. If it has 5, it's a pentagon, so on and so forth. You get the picture. And then when you get up to n, which is over 12, that would be considered like a 13 gon, 14 gon. You just say the number and then gon afterwards. 27 gon, so on and so forth. Okay, back to our classifications. Is a dodecagon. So it says tell whether the figure is a polygon and determine if it was concave or convex. So for A, it is not a polygon. You might ask, why is it not a polygon? Check out that point right there. It's 1, 2, 3 sides meeting up. Remember, we can only have 2 for a polygon. This one has 3. So that makes it not a polygon. And when it's not a polygon, we don't determine if it's concave or convex. For B, this one, each side only has 2 intersections. All the lines are straight, polygon. And is it concave or convex? This one is convex. Any of these lines that we extend forever will not pass through the interior of the polygon. And C, it is not concave because of this bad boy right here. It's curved. Polygons don't have curved sides, so no. And for D, this one, all of them look straight. It's a closed figure. Yes, it's a polygon. Okay. And is it concave or convex? Well, let's just draw, concave. Okay. Now, if you had drawn this line out, you would have been like, oh, maybe it's convex. You have to draw more than one, okay? Actually, all of them. Because you'll find that these, but sometimes it's only one line that will go through the interior. Okay. And we are going to do, if we go dodecagon, more practice, yay. So now we're going to classify the polygon based on the number of sides and determine if the polygon is concave or convex. So for A, we've got 1, 2, 3, 4, 5, 6 sides. So this is a hexagon. And is it concave or convex? Well, we're about to find out. Let's go ahead and draw a line through here, through here, through here, through here, through here, through here. Never going to pass the middle, so convex. B, 1, 2, 3, 4. 4 sides. 4 sides is a quadrilateral. And is it concave or convex? Convex. Why? Because it does not pass anywhere in the middle or the interior. And for C, we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 sides. 12-sided figure. Polygon. Interesting name. Dodecagon. And is it concave or convex? Let's just draw one of these lines. Concave. Because that line goes inside the interior of the polygon if we extend it forever. Okay? All right. The whole purpose of this lesson was to find the perimeter and the area of in the coordinate plane, okay? But we first needed to define what polygons were, so that's what we did just now. Now, it gives us some definitions. So we've got perimeter and area of this triangle, perimeter and area of a square, perimeter and area of a rectangle. We are going to be using these. That's all I want this slide to be, is a reference tool for you guys for this portion. Reference. It's going to be side A plus side B plus side C. Next, find the perimeter of ABC with vertices -2, 3, 3, -3, and -2, -3. Let's go ahead and plot point A. I think green will not show up here, so let me use red. -2, 3 is right here. Let's label that one A. -3 is going to be right here. Let's label that one B. And -2, -3 will be right here. Let's label that one C. Okay? Now, let's go ahead and draw the straightest lines that we can. That was actually pretty good. That was not so good. And that one's even worse. Well, anyways, we have a triangle now. And what we have to do to find the perimeter is, if we look back at C. So we can label this A, B, and C. Side A is from A to C. Side B is from A to B. And side C is from B to C or C to B. You could have labeled any of these the opposite way. So it could have been CA, BA, BC if you wanted to. So let's go ahead and start with our first one, AC. So we're going to calculate what AC is. AC is this one right here. Okay. So we're going to work in blue. And AC will be, normally we would do, actually let's do it like that. So AC is equal to, we're going to take the distance formula. So A is right here and C is right here. We're going to take the x coordinates and we're going to find the difference of them. So it's going to be -2 minus -2 squared plus the y coordinate differences. So we've got -3 and 3. -3 minus 3 squared. Okay? Now, I'm choosing to do it this way on purpose. A lot of you are like, oh, why don't you just count how many there are? You could do that. 1, 2, 3, 4, 5, 6. But I want to show you guys something cool. So it moves 6 units down, so we know that our answer should be 6. But let's find out how. AC is equal to -2 minus -2 is 0. Because this is the same as -2 plus 2. And that's 0. So now we have the square root of 0 plus -3 minus 3. I'm going to leave it in this form just to show you guys something, okay? So AC is equal to, the 0 goes away, and we have -3 minus 3 squared. Okay? Now, you might be thinking, oh, but it's the square root of something squared. Therefore, it has to be -3 minus 3. But be careful, guys, because when you square something, it is always going to be positive. So that's why we have to add this absolute value here. Because even though the square root could be positive or negative, when you square something, it is always positive. So this is going to be the absolute value of -3 minus 3. Now, I told you guys, when you guys have a vertical or a horizontal line, you can forget about one of the coordinates. For example, our -2's here in the x spot for both A and C are the same. Therefore, we knew it was going to be a vertical line, and it's changing 3 units to go from 3 to -3. I'm sorry, it's changing 6 units to go from 3 to -3. So therefore, our answer is the absolute value of -6, which is 6. Okay? All right, now when I do CB, I'm going to do it the easy way. Okay? So let's go ahead and do CB, which is this section right here. The easiest way would just be to count 1, 2, 3, 4, 5. 5 units, but we're going to do BC equals, and let's go ahead and check it out. So I need to erase this part. What? All right, so let's go ahead and check out BC. So we've got the x coordinates, which are -2 and 3, and the y coordinates, which are -3 and -3. If they're the same, take them away, and you're just going to do the absolute value of -2 minus 3, which is then the absolute value of -5, which is +5. Okay? So we've got 6, we've got 5, and now we're going to do our tough one, which is A to B. AB is equal to, let's use our distance formula, and let's figure it out. Okay, so A and B, 3 minus -2 squared plus -3 minus 3 squared. And this is going to be equal to the square root, I'm going to need a little bit more space, of 3 minus -2 is 5 squared plus -6 squared, which is the square root of 25 plus 36, which is the square root of 61. And finally, what we do is we add all of these together to get our final answer. So our perimeter is AC, which we calculated, which was 6, plus AB, which is what we calculated, which was the square root of 61, plus BC or CB, which is 5, and we get 11 plus the square root of 61 by combining the 5 and the 6, and then the square root of 61 will stay like that. That is our answer for example 3. Some of the questions on your homework will be more difficult than this. Some of them will be less difficult than this, okay? But just make sure that you take your time and you answer all of them. All right, moving on. So find the area of triangle DEF with vertices D at 1, 3, E at 4, -3, and F at -4, -3. So let's go ahead and get this one started. So let's go ahead and plot all the points that we have. So we have 1, 3, which is D. We have E, which is at 4, negative 3. And then we have f, which is at negative 4, negative 3. Wow, this one's going to be awesome. Look at that. We're going to find the area of this triangle. So for our base, we could make any side technically our base. The easiest one that we can make it is this bad boy right here, FE. The reason that's going to make it easiest is because this right now is a horizontal line. That's going to make things so much easier, okay? So since it does a horizontal line, FE, remember, is going to be equal to just the absolute value of the difference in the y coordinates. So let's look at the difference in the x coordinates. F's y coordinates, negative 3, and E's y coordinate, negative 3, are going to be neglected because they are the same. So all we're dealing with is E, which is 4, E's x coordinate, minus negative 4, which is F's x coordinate. This is going to be equal to 4 minus negative 4 is 8. The absolute value of 8 is just a regular 8. So we know that our base is 8. Okay, now the height. The height is that third coordinate that you didn't use for the base, and you're going to draw a line straight down that makes a 90-degree angle with the base, and this is going to be your height. How do we figure out the distance of the height, or the length of the height? Is you would have to use the distance formula. Lovely. So for DEF, this one is going to be, well, right now we can find out that this is 1, negative 1, 2, 3. So this, we'll label this point G. G is 1, negative 3. And then when we're finding the distance, our 1's are the same in the x coordinate, so we don't have to use those. So DG is equal to absolute value of negative 3 minus 3, which is the absolute value of negative 6, which is 6. So our area for a triangle is 1/2 the base times the height, which in our case is 1 over 2 times 8 times 6, which is 4 times 6, which is 24. So it is 24 units squared. Okay, whenever you're talking about area, you're talking about units squared. And whenever you're talking about perimeter, you're talking about regular units, because that's the distance around it. And that was our last slide. Here's your homework. Good luck. If you have any questions, let me know. I hope you guys have a wonderful day, and I will see you guys back in class tomorrow. Bye.